Welcome to STEM School. Introducing cubic equation. The general cubic equation is ax cubed plus bx squared plus cx to power 1 plus dx to power 0, where x to power 1 equals x to power 0 equals 1. And therefore we can write cubic as y equals ax cubed plus bx squared plus cx plus d. The cubic can also be written as y equals x is a common factor in the first three terms. The first three terms, I can take x out. X cubed plus x squared plus bx plus c plus d. Now, the brackets remind me of a quadratic. So y equals x quadratic equation plus d. So that's a cubic equation. But this is the most common way of writing cubic. There can be, if there's 0, if any of the coefficients is 0, the variable terms will disappear. The polynomial here has degree of polynomial which is DOP equals 3. That means it's got the highest exponent is 3, and that implies that it will have 3 roots which we can call alpha, beta, and gamma. Give an example. That could be 2, 1, and 5. So it could be any value, any number. It means it will have 3 factors. Factors will be 3, and that would be x minus alpha, x minus beta, and x minus gamma. That's 3 factor. An example would be x minus 2, x minus 1, and x minus 5. It will have turning point. It will have 2 turning points. Which we call the vertex. And the turning point can be found by saying degree of polynomial minus 1. In this case, 2. 3 minus 1 is 2. So all these, actually, it's pretty exciting because you get to understand how polynomial behaves. The most important thing here we're going to go for is the graphs. So we're going to talk about graphs. As you can see, there are different types of graphs you can get for a polynomial, a cubic. So I'm just going to talk about those. There are 8 types of graphs I want to talk about. 8 graphs. So I'm going to start by saying maybe I'll do the first 4 here. So that's the first 4, and the next 4 will be there, next 4 will be there. So the graphs I'm going to talk about. The first one I'm going to talk about, we draw graphs from left to right. And this is the second quadrant here, and that's the third quadrant. First quadrant, second, third, and fourth. We only draw graphs from second and third. The cubic is positive when we start from third, A is positive, and A is negative when we start from second. So I'm going to draw my first cubic graph. Right, so that's the first cubic graph, where in this graph, may I say, this graph is actually y equals x cubed. Just x cubed. A is positive, plus 1. And the point here indicates that the x factor, I know this graph is written as x cubed, but you can also write it as x minus 0 cube, which means it will have 3 roots at 0. So if you set x minus 0 to 0, you get x equals 0. So here you've got 3 roots. So x equals to 0, x equals to 0, x equals to 0 3 times. So you got 3 equal roots. And the other one that I like to draw is the one that goes from there and comes down gently and down back again. It's exactly the same as that, except this is minus a. I didn't do a dramatic drawing there. Okay, so this one is y equals minus x cubed. So that's that graph for that one. The other graph I like to draw is where you have a cubic with you got 1 there, coming there, 2 and 3. Okay, so that's another one. So you got 3 roots here. It's coming in 1 root, leaving here, coming out to there 2 roots, and going out again 3 roots. So those are the 3 roots. 1, 2, 3. That's alpha, beta, gamma. And when it's coming from this side, you can see it's coming here. Okay, so alpha, beta, gamma. So that's the proper quadratic, cubic. It's got y equals ax cubed plus bx plus c. Likewise, this one is y equals minus ax cubed plus bx plus c. Right, the next graph I'd like to talk about is the one coming from, right, so you're going to get another graph that comes from goes up like that and goes up like that, and likewise comes down like that, goes down like that. So we have got, in this case, we've got one root, so that would be alpha, and here, so that would be alpha, one root, so that's a real root. This is 3 real roots, but equal roots. These are equal roots, so let me just label that carefully. So, so these ones are equal roots. Just to separate that. So that's equal roots, 3 equal roots. Let me just write it here. And on the other side here, so you got 3 different roots. So you got 3 different roots. So that's what you get there. With the blue one, you've got 1 real roots and 2 complex roots. So this one is real root, so that's alpha, and this one here, it's a complex root. So that's a complex root, and that is a complex root as well, because it did not cross the x-axis. Only one real root, so you got 3 same roots, the real equal roots, the red ones. The green ones are the 3 different real roots. 3 different real roots. And the blue one is 1 real root and 2 complex roots. The final one is when you have a root that comes in like that. So let's draw this carefully. So you got 1 going there, and it comes back here, touching the x-axis, and goes like that. So fantastic, isn't it? And you might have the same coming in there, touching the x-axis, maybe going there. Right, so what do we have? We've got, so that one is 2 equal roots, but they are real equal roots. Likewise, that one too is equal roots, and that one is 1 real roots, and that also is 1 real roots. So that is the beauty of cubic equations. Don't forget the 3 factors, 3 roots, and you can write it in terms of quadratic. So you get x bracket quadratic equation plus d, and the beautiful 8 sets of graphs you could be tested off from in the exam.